There are two main parts to any scientific experiment: data collection and data analysis. Scientists can collect all the data they want, but it won't mean anything until they've analyzed it. One of the best ways to analyze and visualize data is to make a graph. We've seen that we can collect different types of data, but not all types can be represented in the same way. So what are the most common types of graphs? And how do I decide which one is right for my data? Let's start off with one of the simplest types, the pie chart. A pie chart is easy because unlike most graphs, it has no axes. Instead, it's just one big circle. A pie chart can be used to visually compare parts of a whole. The entire circle represents 100% of something. Each section, or slice of the pie, represents a percentage of that whole. For example, a pie chart could represent all the things a student does with their day. The whole circle would represent the entire day, and each slice would represent how much time they spent on each activity. For example, a student might spend 50% of their day paying attention to their teacher, 25% of their day chatting with friends, 10% doing other random things, 10% eating lunch, and only 5% walking between classes. Notice how all the percentages add up to 100%. So what if the data collected is a bit more complicated than just dividing up a whole into different parts? What if your data has different variables you want to compare? Well then, it might be better to use a graph with axes. Remember, when you have a graph with axes, you must always label them. The simplest graph with axes is a bar graph. When making a bar graph, you will have two axes. The x-axis will usually represent different categories, and the y-axis will usually represent some type of quantitative value. The length of the bars represent the value assigned to each category. Categories can be anything from colors to types of fruit to subjects in school or months. The values on the y-axis can be anything from age to hours passed to a number of people. Let's say you took a survey of students' favorite seasons. On your y-axis, you would put the quantitative variable, the number of students. On the x-axis, you would put the categorical variable, the seasons that they could choose from. The bars on the graph show how many students chose each season. Notice in this graph that summer was the favorite season and fall was the least favorite. Bar graphs make it easy to compare different categories because you can quickly see which bar is the tallest. Bar graphs can also get a bit more complicated. For example, if you want to compare how males and females feel about the different seasons, you could create subcategories by using different colored bars. You can have multiple subcategories, but make sure you don't have too many, or else the graph might become difficult to understand. While a bar graph is great for comparing the values of different categories, if you have categories with different values that you want to track over time, then you might do better with a line graph. A line graph is great for tracking trends over a period of time. The passage of time is shown on the x-axis. It could be in months, years, or weeks. And the value is shown on the y-axis. Each category is represented by a different colored line. For example, if you wanted to show how fast food sales in the UK have changed over time, you could use a line graph with the number of sales on the y-axis and the years on the x-axis. You could then add your data for each category of fast food. In this graph, we are comparing hamburgers, fish and chips, and pizza sales. Notice how each category is represented with a different colored line. The final type of graph we are going to discuss today is a scatter plot. Unlike a line graph, A scatterplot is best to use when the relationship between the two quantitative variables is unsure. You plot the data to figure out how the two variables are related to each other. For example, if you want to know whether the number of years of education a person has is related to their monthly salary at their first job, then you could use a scatterplot. The monthly salary would be put on the x-axis, and the years of education would be put on the y-axis. Then you would plot your data. After all the data is plotted, you can graph a trend line, which shows the average trend of all the data. This helps us know how the two variables are correlated or related. In a future video, we will be discussing the different types of correlation and what they mean. So remember, there are many different types of graphs that visualize different types of data. So next time you need to visually represent some data, ask yourself, which type of graph is best?